Hi guys, welcome to today's coding challenge. Today we're going to be making Conway's Game of Life, which you can see on the screen here. And it's got a few features added in, including being able to draw and clear the screen and things like that. So let's jump into it. I've got here a blank processing sketch, and so there's nothing in it, just the setup and draw functions, so let's go. So the first thing we're going to do is we're going to create an integer array called cells, and this is going to hold all of the cells for Conway's Game of Life. So it's going to have zeros and ones. We're going to use just integers to store whether a cell is dead, which is 0, or alive, which is 1. So yeah, and then we're also going to set a size for how big the cells are going to be. So we're going to call that, we'll call it scale, because that's the scale of the cells. So we're going to have it, I don't know, it's 20 sounds alright. And then we're also going to have another integer called size, which we're going to leave unset for the moment, because we're going to use that to store how many cells are in the width and the height of the screen. So we're going to set the screen size now, and I'm going to set it to be a square. So I'll go 720 by 720. I'm going to use a square just to make it a bit easier, so that we've got the same number of cells across as we have up and down. So then we need to calculate the size, which is the number of cells, and to do that we're just going to go size equals width on scale. So if we were to have a rectangular screen instead of a square screen, we would have to calculate different sizes for the number in the width and for the height. So we're just going to leave it as just 1 for the moment. We're going to have it as a square because it'll make it a lot easier. So the first thing we need to do is we need to put some values into this cell array, because without it we don't have a Game of Life. So I'm going to do a little for loop. I'm going to go int I is less than, I equals 0. I is less than size times size. Actually, we need to initialize the cell array. So we need to go cells equals new int array, and it's size times size, like that. So this is just creating the cell array to have size times size things in it, and we got that many because size is the number across, and we've also got a bunch of rows, so size times size. So then I is less than cells dot length, and then I plus plus plus. Okay, so we're going through every element in the array, and we want to randomly populate it so that some of them are alive and some of them are dead. And to do that, we're going to say if random 1, so this will get us a random number between 0 and 1. If that is less than 0.5, then we want to say that cells I equals 1, and then we want to say else. Otherwise we want cells I to equal 0, so that means it'll be a dead cell. So what we can do is I might actually change that to be a variable called chance, and then we'll put a float chance 0.5. So this will just mean that we can change how many spawn if we want it. So at the moment, if we run this, we'd get a blank screen, but we'd have a cell array full of zeros and ones. So I think we should try now to get that displaying on the screen, and to do that I'm going to make another function called draw cells, like that. So to do this, we're going to have a for loop, and so at the moment our cell array is a one-dimensional array. Like there's just one huge list of zeros and ones, but we want to display it as a square. So to do that, we're going to have two different arrays all going through. Two different for loops. One with I, one with j, and instead of having it less than cells length, we're going to have it less than size. So this will go through the entire array of cells in a way that makes it really simple for x and y coordinates, because we'll have the I and the j. So we want to go if cells... Okay, so to get the coordinates, to get the index of the cell from its coordinates, we're going to have to do something a little tricky, and I've drawn up a little picture. So we're going to make a function that translates those coordinates into just a position in a one-dimensional array. So we're going to call it pos, so it'll return an integer and it'll take an int I and int j. Okay, so we want to, firstly I think we want to constrain I to be between 0 and size -1. And also, I need to go like this, and do the same for j, just so that we never get ones that are outside the bounds of the array. Okay, so then we want to return I plus j times size. Okay. So now going back to the drawing of cells, we want to find out if cells at the position I and j equals 1. So if it's an alive cell, we're going to draw a rectangle at I times scale, j times scale. So we're shifting it, because each cell is 20 pixels wide, we need to account for that when we're drawing it, because otherwise we'd just be drawing them as a single pixel each. So we need to do that, and then the width and height of each cell is just scale and scale. So now I'm not going to draw them if they're dead, because we're going to have the background just be white anyway. So if we go here, background is 255, and then we want to draw cells. Okay, so if we run this now, we should get a bunch of black squares on the screen. So if we run this, we should see... Oh, so I forgot to set the fill to be black, and so they've only just got black outlines. So I'm going to turn off, when I'm drawing the cells, I'm going to say no stroke, because I don't want them to have an outline, but I want their fill to be black, which is 0. So now if we run this, we should get black squares. So there we go, we got black squares. So one thing I want to do is to draw in a grid, so you can actually see better where all the cells are. So I'm going to make another function called void draw grid, and in this we are going to do a for loop, and we're going to go for, well, actually we can copy this. So for I equals 0, I is less than size, and we only need one for loop for this because we can draw the vertical lines at the same time we're drawing the horizontal ones. So if we draw the vertical lines first, vertical lines will start at, they'll start at I times scale. So that's how far across the screen they'll be, and they'll go from 0 and then I times scale, because we want them to be straight line, to height, like that. And then for the vertical lines, we essentially want to do this the other way around, so it's 0, I times scale, width, I times scale. So we should get a bunch of lines all drawn on. And actually, because I turned the stroke off here, it'll stay turned off, so I need to turn it on in here. So I might do like 150, so it's like a light grey, so it's not overpowering. So now we want to draw the cells, and then we also want to draw the grid. And if I'm drawing the grid after the cell so that it actually shows up over the top, because otherwise the cells will get drawn on. So yeah, now you can see we've got some nice grid lines going on, so that'll just make it easier to see things. So what we need to do now is, for Conway's Game of Life to actually work, we need to be looking at the number of neighbours each of these alive cells has, because that's how it determines whether it'll be alive or dead in the next iteration of, like, the next generation of cells. So before we try and get into determining if it's alive or dead, we need to figure out how many neighbours each cell has. So I'm going to make a new function. It's going to return an integer called num_n, because I'm lazy. And so it's going to take in an int I and an int j, so that's the position of the cell that we're currently looking at. And we just want to go through, we want to create an integer called num, and we'll set it to 0, so this is the number of neighbours it currently has, and then at the end we'll need to return that, and I'll do that now to get rid of the errors. Okay, so what we need to do is I'm going to do this using for loops. X equals -1, x is less than or equal to 1, x plus plus. So I'm going to do this in little for loops that have only got 3 things in them. So going from -1, 0 to 1, and we'll do the same for the y, because we only need to look at the neighbours immediately next to the cell, so the 8 ones around the outside. So from this position we need to go back 1 and forward 1, and we also need to go up 1 and down 1. So that's why I'm doing it like this. So the first thing we need to do is, because we don't want to count the neighbour if it's itself. So if they're both 0, it'll be looking at the middle of the circle, so that'll be the one that we're actually checking. So we want to skip it if we're at 0, 0. So we go if x equals 0 and y equals 0, we just want to say continue, so that'll go to the next loop of the for loop. And so then we also want to say, so we want to count the number of neighbours. So when they're dead, they've got 0, and if they're alive, they've got 1. So we can just add all of the values up, because if they're dead, 0 won't add anything to the total number of neighbours. So to do that, let's see, I'm going to create a new I called I, and it's going to be I plus x, and we want a new j, which is j plus y. This will just mean it's a bit cleaner when I do this next one, so we want to go num plus equals cells pos ni nj, like that. So what that's doing is it's going for all of the neighbours around it. It's getting the position of that, finding it in the cells, and adding it to the total number. So to test this, we can in the setup here, I'll say print num_n, and we'll just choose a random one to find the number of neighbours of. So I've got 10, 10. And to make this a bit more obvious, when I draw the grid, when I draw the cells, if it's equal to 10, 10, I'll change the colour of it so we can see which cell we're actually looking at. So I'll go if I equals 10 and j equals 10, then fill 255, 0, 0. So that'll make it red, else we'll go fill 0, like that. So now when we run this, we should get a red square and a number popping up down here, and we should hopefully be able to count the number of neighbours. Okay, so something's gone wrong. So it's printed out the number of neighbours, but for some reason... Okay, so we've got this red cell here, and we need to count the number of neighbours. So you can see it's printing out 6, and if we look at it, in these 8 cells that are surrounding it, you can see there's 1, 2, 3, 4, 5, 6 that are black, which means 6 alive ones and 2 dead ones, and we get 6 as the number of neighbours. So if we run it again, we should see a different number, and we can try and verify it again. So yeah, this one here, we've got 2 neighbours that are alive, and these 6 ones here are all white, which means they're dead. So that seems to be working. So I can get rid of this red colouring and the print statement up the top. Hopefully I don't delete the wrong thing. Okay, so we've now got how many cells each neighbour has. So the next thing we need to do is calculate the next generation of cells. So to do this, I'm going to write another function, and I'm going to call it, let's see, I'll call it next cells, like that. So we're going to go through all of the cells, and we're going to find out what needs to happen to the next ones. So to do I'm going to change, we need to copy the cells array that there currently is, and then we're going to change the values in it and then copy it back. So we need to go int array, and we'll call them next equals cells.copy, like that. So we're making a copy of the cells array. Why doesn't it like that? Oh, I think it's not copy, it's clone, like that. So we're going to clone the array. We've got a copy of the cells, and now we're going to go through all of the cells in the array so we can copy this one that we're using for displaying them. We're going to copy that, and we're going to use that to go through them all to check if they survive to the next generation or not. So we want to get the we're going to say int n equals num neighbours of the current position, so I and j. And then we want to say, so we want to check if the current cell is alive. So if cells, what is it, pos I, comma j, if that equals 1, so if we've got an alive cell, we want to see if it should survive. So if it's alive and it's going to stay alive, we don't need to do anything to it because the next is already a copy of the current cells. But if it dies, we'll need to change it in that next array. So the conditions for it dying is if n is less than 2, it'll die because of underpopulation, or if n is greater than 3, I think. Any cell with more than 3 living neighbours dies. Yeah, so if n is greater than 3, it also dies. So if that's the case, we need next at pos I, comma j. We need that to equal 0. So they've now died. Oh, have a little funeral. Okay, so those are the only conditions for it dying, and then if it's already dead, it can be brought back to life if n equals any dead cell with exactly 3 neighbours comes back to life. So if n equals 3, then we say next at pos I, comma j equals 1. So it gets brought back to life. And I need to put a closing bracket in here. And so then at the end, we'll need to say cells equals next dot clone. So what we're doing is we're creating a copy of that array, and we're changing all the values in it while looking at this one, because we need to look at the old generation to make the new generation. And then once we've finished changing all the values in here, we're copying it back to this one And so now in the draw function we should be able to say next cells, and we should see that when we run this they're all going to be moving and generating, and we'll see what happens. So when we run this, yep, you can see they're bubbling all over the place, but they're doing it really quickly. So what we might want to try and do is have a way of regulating how quickly the simulation happens. So we can do that using processing got a frame count, so it counts the number of frames. So if we say if frame count modulo, I don't know, like 20, so every 20th frame, if that equals 0, then we can get the next cells. Otherwise, we're going to keep it as we're not going to update the cells. So only every 20th frame will update the cells. So that's a bit slow. I might make it 10. So if we get 10, you can see that it's a bit faster, but it's still pretty slow. Maybe what we could do is we could, instead of having it as a fixed value, we could have it as a variable, and we could use the keyboard to change that variable up and down. So if we do that, we can have a variable called fr. We'll put it up here. So we'll say int fr equals, well, we'll set it for 10 for the moment, but what we can do is we can, down the bottom here, we can say void key pressed. So this is a built-in function that listens for keyboard inputs. So if key equals, we'll say W. So if we're pressing W, which is essentially like up, if key equals that, then we'll say FR, so it's going up, so we want it faster, which means we want this frame rate thing to go down, because that's the number of frames between each render. So FR minus minus, and then if key equals S, which is down, then FR plus plus, like that. So now when we run this, I should be able to press W and it gets faster, which you can see. Oh, I got an error. Divide by 0. So we'll need to constrain these frame rate variables so that they don't go below 0. And I'll probably put an upper limit on them as well, because otherwise it'll be really slow. So we'll say fr equals constrain, I didn't spell that right, constrain fr minus 1, so we're taking 1 off, to be between 1 and 20, and I'll do the same for this one, except instead of minus 1 I'll make it plus 1, and so now we should see that when we run this I can press W as much as I like and I'm not going to get an error, and then I can also slow it all the way down. Okay, so there are a few other features that I was thinking of implementing. One would be a pause, so that shouldn't be too difficult. So if we say, we'll use the spacebar for this, so if key equals space, then we'll say, well actually we'll need to make a paused variable up here. So we'll make a boolean paused equals false, so we'll start out with it not paused, and then if we press the spacebar we want to toggle it from being not paused to paused. So an easy way to make something toggle with Boolean logic is to have pause equal not paused. So it essentially just flip-flops in between being true and false. So to make the simulation pause, we just don't want to calculate the next cells. So in here, where we're checking if we're at the right frame rate to calculate the next cells, we can also make sure that we are not paused. So if we're not paused, it'll calculate the next cells, otherwise it won't do it. So if we run this now, if I hit the spacebar, we get no movement. So that's good. They're not moving, we've paused the game, and if we press it again, they start moving again. So that's good. Another thing I was thinking of adding is that we could make it so that when we move our mouse around the screen, we can actually draw in alive cells. and we should also be able to delete them. So I'm going to make a function that I'll call it set cell, and it will take in a position and then also a value. So this means that we can use the same function for deleting as we can for drawing, because we can set this value to be either 0 or 1. So we would just want to say that cells at pos ij equals value. Simple as that. So we're going to use the mouse drag function, which is another one of these inbuilt processing functions that listens for mouse movement. So if it's being dragged around, then we want to say set cell, and now we'll need to take the position of the mouse and turn it into a cell coordinate. So to do this, we'll say mouse x divided by size or by scale. I have to test this one out. And then mouse y divided by scale. So, oh, we also need to set in the value, so we want to make them alive when we draw. So let's try this out. Oh yeah, so it's working. So if I pause this, you can see that wherever I drag my mouse, we're getting alive cells. So that's really good. So now to make them deletable as well, I'm going to have a little toggle for whether you're drawing them or deleting them. So I'm going to, up here near the pause thing, I'm going to say boolean delete equals false. So the default will be that we're drawing instead of deleting, and then we'll say if key equals D for delete, then we'll say delete equals not delete, like that. So, and then when we're drawing, we should say if delete, and then else, like this. So if we're not deleting, we want that value to be 1 in the set cell function, and if it is set to delete, then we want it to be 0. Okay, so we should see now that if I pause it, I can draw cells on the frame, and then if I hit the D key, I should be able to, yep, I can now remove them from the frame as well. So what would be really great is, because this lends itself quite well to drawing little pictures, so it'd be great if I didn't have to try and delete all of them by hand. If I could just press a key and the whole screen would clear, that would be great. So I'm going to make a function. We're going to call it, let's see, we'll call it clear. No, that's reserved. We'll call it 0, because we're going to set all the values to 0. And we're going to copy, so in the setup function, we set all of their values to be random values. Actually, we never tested that, did we? Let's try and test that out. So if we change this chance variable up to like 75, it should be mostly black screen. Oh, and they all just suddenly died. And if we change it down to 0.5, they should be pretty much all, yeah, they're all spaced out. Hard to see. I'll turn pause to true, and we should be able to see it better. So when the chance is really low, it's really sparse. There's like not many alive cells. If we set it really high, 85, then it's almost all filled in. So that's great, that's working. So we can forget about that. So when we first set these cells, we're going through all the cells and on a random chance setting them to 1 or 0. So we can copy this and take out the random chance and just make them all be 0, like that. And then that's that function done. So all we need to do is map it to a key. So if we say if key equals C for clear, then we'll say 0, like that. So we should now see, if we run this, oh, it's still paused. If we run this and we hit the C key, it all disappears. And so now we can draw pictures. There you go, a little smiley face. He mutates into just a blob. Or we can write my name really badly with my mouse. Like, oh, I ran out of room. Oh well, thank God I'm not an art channel. So, a few last things that I was thinking of adding. One would be to have a little box show up around my cursor so I can actually see where my mouse is on the screen. So I'm going to do that in the draw grid function. So after we've drawn the lines, I'm going to draw a rectangle. Oh, and to do this we'll have to say no fill, because we don't want it to be solid, and we want the stroke, I'll make it red. So 25500, we'll say we need to take the mouse coordinates and turn them into a pixel to a cell coordinate, and then scale it up again. So it's going to look a bit funky, but we need to do it to turn it into an actual box that sticks to the grid. So we'll say int x equals mouse x on scale. So this is using the same principle as we did before for when we were drawing. So and int y equals mouse y on scale. Okay, so we want to say we want a rectangle at x times scale. So what we've done here, that these x and y values have turned it into coordinates for the cell array, but now we need to scale them back up to the size of the screen. So we go x times scale, y times scale, like that, and then we want them to be scale by scale. So now, when we run this, we get a little box that sticks to the grid, and you can clearly see where you're drawing. So if we didn't do this and we just drew it at the mouse x and y, I'll show you what that would look like. So we'll go here. I'll just type that and go mouse x and mouse y. If we do this, then we just get a box that sticks around our mouse like that. So that's not what we want. We want it to stick to the grid system. So it'll be like this. So there we go. We've got Conway's Game of Life fully implemented in processing. And it's got a few extra features as well. So we can, for instance, pause it and draw our own pictures, or we can delete parts of we can delete cells. We can also clear the whole screen so that we can draw our lovely pictures ourselves, like that. And we can also change the passage of time, so we can make it go faster or slower. So yeah, I hope you enjoyed this coding challenge. There'll be a few links down in the description. First, there's the GitHub page for this, so you can download this code and play around with it yourself. There'll also be a link to the processing website, so you can download processing and get involved like that. And then also my website, which holds, you can post your own topic ideas for the coding challenges and vote on other people's submissions. So yeah, thanks for watching. If you enjoyed this video, please subscribe and give a thumbs up. Cheers.